All right, so now we're at Unit 8, Lesson 2 activity sheet. And we're going to solve some equations in a new and interesting way. You're going to love it. Basically, we learned the rules that you can add or subtract or multiply or divide both sides of an equation by the same thing. That's very important. We're also going to learn another way to kind of solve things for more complicated equations. And the real trick is to take stuff from earlier chapters and see things in a new way. So some of the things we've learned in the past are standard form, which is y equals, no, that's not standard form, ax plus by equals c, and then there's y-intercept, slope-intercept form. Rusty, because I haven't been teaching this for a while. I keep saying the wrong names. Y equals mx plus b. And then the third form we had was point slope form. It was y minus y1. Well, actually, no, it was y minus k equals m times x minus h. We often use h and k. You'll see those in algebra 2 when we're trying to show that the point goes through the point hk, and it's blah 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 blah. Unimportant right now. But the thing is, these are going to come in handy because a lot of these equations, look, they have a lot more stuff in them. They're more complicated, but they have a number times a variable and then another number. And if I add these, I get a number times a variable and a number, except I'll have 7y's minus 5y's makes 2y's. So the 7 is going to turn to a 2 in a second. And we can actually solve this using graphs. Okay, we're going to talk about that a little bit. But it says check your solution using a table. We're going to use algebraic operations to solve this. So the first thing that you need to understand is now we have lots of options. When it says to solve with operations, we'll do that. But there is another way to solve it, another way to think about this whole thing, because there are lots of variables. And it's almost like I have this format twice, once on each side. That's important to notice later. Okay, so let's solve this. Remember, the first step is always to type it out or write it out. 3y equals 7y minus 2 minus 5. Okay, so we've got that. One thing I notice is that these are being added and subtracted, right? So I have a 7y minus a 2, and I'm going to take 5y's away from that. So then I will have 8 minus 3y still over here. And then I'll have 2y's left over here. Minus 2. I still don't quite understand why this whole thing changes size and shape sometimes. 16, all of it. Okay, so now I'm going to take away stuff from each side. When I have variables on each side, my first step is to try to get rid of variables until one of them runs out. This is slightly different because there are negative variables on that side. I don't like negatives, so I'm going to get rid of that. So that's 8 minus 3y's, whatever number y is. And I don't want to take away 3y's. I don't like that because, yeah, I want to subtract something and not even know what it is. So I'm going to add 3y's over here, and that's going to leave nothing but an 8. But that means I have to add 3y's over here as well, which means I'll end up with 5y's on the right side. It's almost like I just took this 3 and I put it on the other side and changed its sign. That is a way some teachers teach it. But because we're trying to teach these properties, I don't do that so much. I more or less just kind of stick with understanding that I'm adding the same amount to both sides. Look at that. So that is great. We got 8 equals 5y minus 2. We're almost there. I want to get rid of all the things around the y. I get rid of the 5 and the 2. We always start with the thing being added or subtracted, so I'm going to get rid of the 2 first. And so I'll add 2. Notice 2 is being subtracted from 5y. So I have 2 less than 5y equals 8. Well, what if I just had 5y? Well, since 2 less than 5y is 8, then 5y must be, you guessed it, 10. Okay, and then I divide both sides by 5, where you just notice that 5 times 2 equals 10. But really, what we would say is we're dividing both sides by 5. Hey, I have an answer. Y is 5. Okay, so what's this with a table, like whatever, right? One way that we can think about this is, I'm going to take this guy right here, and I'm going to be like, well, let's see, what if I had 2 equations? What if I had x equals 2y plus minus 2? And then what if I had x equals 8? Now we'll say negative 3y plus 8. These are the 2 sides of this equation. Okay, so I can make a table and figure out when those make the same number, because this right here is like an equation, right? So what we're really saying is that these numbers are the same. In other words, these 2 things are the same as, these 2 things are the same as each other. We want them to be equal. So we want x to equal x, so that this equals that, just like it says over there. That's kind of what we're doing here. That's the reasoning behind what we're going to do here. So they want us to make a table. Okay, so we're going to make a table for each of these. I'm going to go over here. I'm going to go over here. You'll notice that this table is not great. It's not nearly as fast as just solving the thing. Algebraic solving solutions, just adding both sides and subtracting from both sides, that is 9 out of 10 times the fastest way. But it is good to know other ways, because other ways to solve things, because you never know if a certain tool might work better. X, Y. Over here 2, X, Y. Okay. You know what? I should list them in another order, but who cares? I've already done it. So let's stick with it. Shift so I can make a straight line. Almost there. It says to use a table. We're going to use a table just like it says. Now you can do this with graphs also. If you remember, in the last chapter or 2, we graphed some of these lines. We graphed stuff like this. It has a slope of 2, and it has a y-intercept of -2. It's this right here. So you can also, we'll look at ways to graph to solve these. But right now it's asking for a table and a graph. We'll take a look at the graph, actually. I'm not going to graph it here. Okay, so let's type in some numbers. What if y is 0? What if y is 1? What if y is 2? And what if y is 3? We're just going to take those numbers randomly, although actually we know already that one of them is going to be the answer. It says y is 2. And we'll see what that means. We're going to try to make this guy equal to that guy. Why? Because that's what it says right here. They're equal to each other. Okay, that's our goal. So let's figure out what happens. If I plug in a 0 for this one up here, I get, let's see. This is ugly. There. That's where it's supposed to be again. So the top one. If y is 0, I get -2 for x. If y is 0 up here, I get 8. Notice they're not the same number. Huh. Well, that's not great, because I want this to make the same number as that. So if y is 0, they don't make the same number, do they? I wonder what they have to be, what y has to be for them to make the same number. Well, if I plug a 1 in here, you can do the math, but I end up with 2 minus 2 is 0. Right. Over here, if I plug in 1, I get negative 3 and 8. That makes 5. I hate it when that happens. Okay, great. Still not the same number. 0, 1, and 5, 1. The x part, what it makes, is not the same. What if I plug in a 2? Well, if I plug in a 2, I get 4 minus 2 is 2. If I plug in a 2 here, I get 8 minus 6 is 2. Oh my goodness. Look at that. Math works. Here, they're the same. Oops. They're the same thing. I don't even need to go on to check the 3. If you want, we can, but I figure you're probably more interested in when y equals 2, eight minus 3y will equal it will equal 2y minus 2. That's what we just figured out. That's the goal. Right there. Okay, so if you can do that, then great. Now, I will say we can also, you could have a graph. You could graph them. Now notice one has a y-intercept of negative 2 right here. So, and it has a slope of 2, so it goes like this. Something like that. We're just sketching this graph. This one has a y-intercept of 8, somewhere up here. And a slope of negative 3, like, I don't know. Something like that, I don't know. If you graphed them all on a graph, you would find that the point that they cross right here is the point, you guessed it, 2, 2. Although yeah, it's fine. What I ended up having is a y-axis here and an x-axis there. You'd still get 2, 2. It would look different because the x and the y are switched up here. If you switch, yeah, I switched to the graph to fit this. So this is like, usually we have y equals mx. This is x equals my. So I just flipped the thing so I could graph it the same way that I usually do. And so notice, that's the same thing. They all mean this. When y is 2, then the two sides will be equal. Okay, let's see if we can solve this one, and then we'll get to some fractions. Check your solution using a table and a graph. Okay, so here's what I'm going to say. It is a useful thing. We will type this in to an equation into the graph, but I'm not going to be drawing these graphs because it takes forever. And yeah, maybe we'll do it more in class, but it's not worth it for an old assignment like this. We'll just check to see how it works. We're going to check using a calculator. Check by plugging in the solution. Why? Because that's what I would do. Okay, so we'll try that in a moment. Okay, just so that you know, because we can find the solution. So why would we check 2 or 3 different ways? Well, the answer is to try to get used to graphing, but this is not how graphing works. What we're doing right here, you'd have to use a calculator, and we can use a calculator. on Desmos, so what it looks like. But we're not going to copy and paste it. Well, no, we won't. Okay, so we've got 4 times k minus 3 plus 7 equals 2k minus k minus plus 8. That's fun. Okay, great. So we've got this lovely stuff. I'm going to distribute. Okay. So distributing is really important to remember how to do, because we get ourselves into trouble if we don't distribute correctly. When you have parentheses, remember this 4 is being multiplied by k and by -3. This negative, I'm subtracting a k and I'm subtracting the 8. So it also distributes. Okay, I'm just subtracting the whole thing. So what that ends up being is 4 times k is 4k. Minus 4 times 3 is 12. Plus 7. Okay. Minus k, also minus the 8. That's what we end up with. Okay, and notice I have 4 k's and I have a -12 and a 7. I can put those together. They're just regular numbers. That's the same as 7 minus 12. -12 plus 7 is the same thing. So what does that leave me with? Well, I subtract them, which makes 5. But I have to make the bigger one is the sign that wins. So the negatives win because there's a bigger negative number. So I end up with -5. So I end up with 4k minus 5. 4k minus 5. No idea, again, this keeps changing size, but that's okay. We'll go to here and keep going. All right. Plus or equals. Here I have 2k's minus 1k. Well, if I have 2k's, 2 of anything, and I take 1 away, that just leaves me with 1. Okay, there we go. So now I'm going to take away a k from each side. I have 4 k's on this side, I have 1 k on that side. But here, I just want you to understand, if I had a graph next to me, I could say, hey, look at this. I've got a line and another line, and one has a slope of 4 and -5, and a slope of 4, so it's a really steep line like this. And then another one has a slope of, it crosses at -8, and it has a slope of 1. Something like that. So these 2 lines are going to cross somewhere down here. X is going to be one number, yeah. The point is, we can figure out the answer, and we'll take a look at that when we get to Desmos, okay? But I can kind of graph these using slope and intercept. Okay, moving on. This is a long assignment. It's going to be a long video, probably. Okay, so I take 1k away from each side, and I end up, there are only 3 k's over here left over. And there's no k's left on the other side, but there's still the -8. Now I've got to get rid of all this stuff. So I'm going to add 5 to both sides. And that's going to leave me with 3k. And -3, because I added 5 to the right side. It got 5 bigger, so it's at -3 instead of -8. On the left side, I added 5, so this disappeared. Finally, I divide by 3, and the only thing I multiply times 3 to make k is, or to -3 is -1. So k equals -1. I got my answer. Oops. So here's how I would check this. I would plug it in here. Wow, I'm great with a mouse. Okay, so we have 4 times -1 minus 3. We're going to see if it really does work. Because the whole goal of algebra is to figure out, well, I got this crazy thing here up at the top. Does it work? What number will make that work? What number will make that be equal, like it's supposed to be? 2 times -1 minus 1 plus 8. Okay, that leaves me with 4 times -4. Times -1 is -2 minus 7, because 8 and -1 adds to make -7. Okay, we're almost there. Let's see. That's -16 plus 7. Over on the right side, we have -9. The question is, does -16 plus 7 make -9? Indeed, it does. -9 on the left side, -9 on the right side. That's it. I just showed that if I plug in -1, then I get 2 equal amounts on the left and the right side. So what we can say is, when k equals -1, the equation is a true statement. All true. In other words, the only thing that will make this equal, this left side equal to this right side, is if I plug a -1 in for k. Okay? So reminding ourselves how this works, this right here was a step. I just use regular math to turn it into this. I'm going to create 2 graphs. I'm going to go into Desmos really fast, and I'm going to create a graph of this and that. We're going to see what that looks like. 4k minus 5 and k minus 8. Desmos, here we come. Okay, we're going to change the k to a, well, maybe we can. Let's try 4k minus 5. Yeah, it doesn't like that. We're going to use x and y because that's what it likes to use. So we're going to change the k to a y because that's what Desmos likes to create. And then, never mind, 4xy equals 4x minus 5. There we are. Okay, so I'm just kind of changing it into what we're used to, the y equals mx plus d format, just for the record. So I'm just taking this and I'm saying y equals 4x minus 5 and y equals 1x minus 8, or just x minus 8. Y equals x minus 8. Okay, and just like I had drawn here, we have a shallower line that's further down, and we have a steeper line that's further up crossing this line, because this has a slope of 4 and it crosses at -5. And this one has a slope of 1 and it crosses at -8. Okay, so here's what it looks like in an actual Desmos. And where do they cross? They cross at -1, -9. In other words, when I plug a -1 into each of them, I get a -9 out. So if I were graphing them, they'd be at the point -1, -9. So there's a lot of ways that these things are related. Okay? Okay, we're going to solve this equation, and we love ourselves some fractions, I'm sure. Here's an important rule. We can multiply both sides of an equation by the same thing. Always. One other important rule is we have to multiply everything on that side by the same thing. So what I'm going to do with this problem, I'm going to what we call cancel out. Now I'm going to clear the fractions. This is a really good trick. Get rid of fractions using multiplication. Okay, that's a very important trick because nobody likes themselves in too many fractions for some reason. And the frustrating thing is I'm going to have to write for the first one. Okay, so we're going to have a b and a 3 and a 5 and a 3/2 and a b and a 1/3. Okay, I know it's ugly. Hang in there. Okay, so here's a cool trick. All right, you have learned this way back in the day, but now we're actually using it, so it might seem weird. Okay, you might have learned greatest common denominator or something like that. That's what we're going to multiply by. Here's what we're going to do. We're going to multiply by a 3 and a 2. Because I'm in a hurry, I'm going to multiply by both at once. So that's 3 times 2. That makes 6. So I'm going to multiply by 2 and then 3, which is really just multiplying by 6. I'm going to make everything every term by 2 and 3. By 6. Okay? You know what? I'm just going to say by 6. That's going to be it. Okay. This is very important. That's what we're doing right here. That's what we're doing. Now, if I multiply everything by 6, here's what I get. I multiply this guy, this guy, this guy, and that guy. Each term has a plus or a minus or an equal sign between it and the other ones, okay? So there are 4 terms, and I'm going to multiply each of those by 6. That's a big mistake people make when they multiply both sides. We're used to the really easy ones where there's just one thing on each side and we multiply by 6. What if there's 2? I have to multiply each term, everything, all 4 of those things by 6. So here's what I end up with. 6b, 5 times 6 is 30, equals 6 times 3 is 18. And 1 times 6 is 6. I've got to do the bottom row. There's still a 3 here, right? We haven't gotten rid of it. We really have, but you'll see how we did in a moment. So these are the bottoms of my fractions. Let me write in that line. We're done with fractions for the rest of this assignment. Or not assignment, but this problem. So why did I multiply everything by 6? Well, the first thing is I can multiply both sides of something by 6. If I make this side 6 times bigger, and I make that side 6 times bigger, then they should stay equal, right? That's one of the rules we learned. But I have to make sure that I multiply everything on each side and make it 6 times bigger. Okay, the next rule is, well, the reason that I chose 6. Well, if I make b 3 times bigger, then that's going to cancel out with this 3. And notice, I made it 6 times bigger. So now I can divide these. 6 divided by 3 is 2. And here I can divide this. 18 divided by 2 is 9. And 6 divided by 3 is also 2. So what ends up happening is all of the fractions work out nicely now. Why did I choose 6? Because when I make things 6 times bigger, 2's and 3's will divide evenly into 6. That's why I picked that number. So it gets rid of these guys when I multiply later, when I divide later. So here's what we end up with. 6 divided by 3 is 2. 18 divided by 2 is 9b, and plus 2. There, that's nice and pretty, isn't it? Okay, we're going to subtract 7. No, we're going to subtract 2 b's from each side. Minus 2b, minus 2b. So if I take 2 b's from the left side, it's gone. If I take 2 b's from the right side, there are 7 b's left. Okay, I'm going to take away 2 from each side. Leave me with 20 on our left side. And now I have to divide by 7. If I make each side 1/7 as big, I get 4 equals b. 4. 28 divided by 7 is 4. 7 B's divided equally 7 parts makes 1 B. If I split $7 between 7 people, they each get $1. That's what we're talking about here. Okay, so B should have to be 4. Let's see what happens when I plug a 4 in here. Okay, so plug in to check. I get 4 divided by 3. Equals 3, 4 plus 1/3. Okay, now I'm going to put a 3 here, 2 there, 3 there. Ugh. Now this is the type of math that a lot of people, most people in the class, would not want to do in their brain. How am I going to make these fractions add to make the same thing? That's ugly. Ugly math. I wouldn't like doing it. But this should work. So 5, that's 5 1/3, 6 1/3. On the left side. 3 times 4 is 12. 12 divided by 2 is 6. Equals 6 plus 1/3. Both sides make 6 1/3. Hey, look at that. They are equal. So if I plug in 4 for B, I get 6 1/3 out from each side of this equation. From each side of this equation. And so 4 must be my solution. If I make B equal 4, then each side of the equation will make 6 1/3. Thus, the sides true. I can't keep misspelling true. And there we go. Okay, so that's the way this works. Oof, these things fly by slowly, don't they? Okay, now we're going to clear fractions again. 2 and 5. What do 2 and 5 both go into? I hope you got the number 10. So I'm going to make everything 10 times as big. Okay, now here's how that'll look. Times 10. Okay, that's what I'm going to do. And here's what it looks like, my first step. And then I won't have any fractions. It'll be nice. I have 10 on the left side. 10 times x minus 3. I have to multiply both the x and the 3 by 10. I'm not going to bother to write it separately, and you'll see why in a moment. Don't say 10x minus 30. I could do that, but it's easier since I have to divide everything by 5, just to leave it separate, and I can divide the 5 before I distribute. And here's how this works. I multiply this side by 10 as well. 10. 10. X minus 6. Here we go. I just have to divide by 5 here. By 2 here. Boom. Okay. Fractions, and we've got an equation. Now here's the cool thing. Since this is being multiplied by this, I don't have to divide by 10 each of these by 5. I only have to do that when there's addition or subtraction involved. Since these two things are being multiplied, they're like one number. Okay? So I don't have to divide the x minus 3 by 5 as long as I divide the 10 by 5. Okay? Remember, the terms are separated by pluses and minuses, by the pluses and the minuses. They're not separated by multiplication. So this, not two terms. This is one term. X, the 10, the x, and the 3, they're all one big thing being multiplied. So when I divide, all I have to do is divide the 10 by 5, and I get 2 times x minus 3. And over here I get 10 divided by 2 is 5 times x minus 6. And I end up with, I distribute now finally. I'm going to distribute. I'm going to get, might as well do this. Here we are. My dog is sleeping next to me, starting to have a dream. Dream away, Bruce, dream away. Okay, so that'll give me 2x minus 6 equals 5x 30. Now, if I were going to graph, I could graph these. This has a slope of 2 and a y-intercept of negative 6. And I could graph a line. This has a slope of 5 and a y-intercept of negative 30. I could graph those two lines on here, and it would tell me the answer. But I'm going to use algebra because that's a much more useful tool to us right now. I'm going to take away 2 x's from each side. That'll leave no x's on the left side. What just happened? 32. Taking away 2 x's, so that leaves me with just a negative 6 on this side. And it leaves me with 3 x's left over on the right side, minus 30. Okay. I'm going to get rid of everything on the right side here. I'm going to add 30 to get rid of this guy. I'm going to make everything 30 bigger. So instead of having 30 less than 3x, I'm just going to have 3x on the right side. So here's what it'll look like when I add 30. I end up with 24 right here. I end up with 24 right here. And 3x right there. And that's it. Now I divide by 3, and I get what goes 3 times into 24. I believe that that is 8. So x is 8. And there we go. That's the answer. You can put it in here and find out. We get 8 minus 3 is 5. 5 divided by 5 is 1. 8 minus 6 is 2. 2 divided by 2 is 1. So they both make 1. 1 equals 1. And it does. 1 does equal 1. Okay, so I'm going to show this one slightly faster. It's the same thing. The thing you need to notice is 7 and 3. If I want to get rid of those, I multiply by something they both go into, which is 21 times 21. Let me do this one faster. I'm going to try to talk less. So I end up with 21 times 2x plus 11 equals negative 21 negative 2x minus 3. Checking these things takes forever. I'm very sorry, but it's just the nature of the year. If you want to do it with pencil and paper, by all means do. I will say, showing all of the steps is important right now. It is very important. As time goes by, you will find that you can skip steps and be like, hey, everybody knows that. And that's what you'll find in a lot of math books later on in math, is they don't bother to write. Notice I stopped saying what I subtracted from both sides. Most math books don't do that. Why? Because it's kind of a waste of ink and space. And if you can get your brain around what's going on, it's not too hard. Notice 21 divided by 7 is 3. 2x plus 11. And 21 divided by 3 is 7. Now this, here's a shortcut for you. 2x minus 3. Do you guys remember? Oops, I said y instead of 7. Okay. Do you remember the cross multiplication? That's what just happened here. Why did that say y again? I can't seem to change that to a There we are. Notice I just multiplied 7 times this guy and 3 times that guy. That's what ends up happening. And we said that that was a rule that could work. So cross multiplication, also perfectly okay. I'm just kind of trying to coach you on ways to get rid of fractions if you ever get stumped. Okay, so now we got 6x plus 3 equals negative 14x minus 21. And then I take away, let's see, I'm gonna add 14 x's to both sides. That's gonna get rid of this, and if I add 14 to this, I get 20. So I'm gonna put 20 x's on the left side, plus 33 equals negative 21. Okay, I'm gonna get rid of the 33 here. Subtract 33, that's gonna make this a bigger number. That's gonna make it negative 54. This has an ugly answer. So I take away 33 and I end up with just the 20x on this side. The 20x equals negative 54. Ugh, that's ugly. I divide by 20 and I get that x equals negative 54 divided by 20. That's little. Half of each of those is 27 divided by 20. No, divided by 10. Which is actually a negative. I divide by 10, something by 10, it just scoots the decimal over. So that's really equals negative 2.7. And this is how you do math without a calculator. This is how people did it for hundreds of years. Okay, so that's the answer. I'm not going to bother to check it, but it does work. It should work. You can try it if you want. It'll be an ugly number, but it should be the same for each of them. Okay, here we got this one. I'm going to use cross multiplication this time because you have learned that, and I forgot about it at first. And so what I end up with is 5 times x plus 4 equals 8 times 3x minus 7. That's a shortcut. See that? I don't have to do the first step here and cancel out the fraction if I use cross multiplication as my reasoning. Okay, now I distribute. So 5 times x is 5x. 5 times 4 is 20. 8 times 3x is 24x. And 8 times 7 is 56. Negative 56. Okay. And now I'm going to take away 5 x's from each side. And then I'm going to add 56. And then I'm going to divide by 19. Ugh, these are some ugly numbers. 76 divided by 19 equals x. Over here. That's the answer. Notice 76 over 19 is not an easy number to get. You might have been able to figure out the first one by being like, hey, I can figure this out just by fiddling around with the numbers in my head. C, not so much. Not so much. And that's why we're learning these tricks. We're solving this using algebraic operations. We're going to check our work by graphing. Okay, great. Okay, we're going to graph these ones. It's going to be awesome. So when they're saying check by graphing, they're asking you to think of these as two separate lines. Actually, I'll make this one black and I'll make it bigger. There. So I got this line. I got this line. So the way to solve this using graphing, just for the record, is to graph the lines where y equals x plus 2 and where y equals x plus 5. Now, ostensibly, like originally, we're just saying, when will a number plus 2 be equal to a number plus 5? Think about that for a moment. Is there a number where if I add 2 to it, it makes the same thing as if I add 5 to it? I had 10, and I added 2 to it, I'd get 12. If I added 5 to it, I'd get 15. That's not the same number. 12 is not the same as 15. You start running into a problem. So just looking at this, I know that there's a problem here. We're running into an issue. Part of why we're showing it on a graph is to figure out what that issue is. So let's try to solve this using algebraic operations like we were, and then we'll graph it to see what's going on. So x plus 2 equals x plus 5. All right, I'm going to take away x from each side, because I can do that, right? I'll even type this one in, minus x. Yeah. Okay. That leaves me with 2 equals 5. Now this is a really cool thing about algebra. It does not lie. It doesn't give you wrong answers. It just sometimes gives you an answer that says, hey, something's wrong with the question. Something's wrong with the original thing here. So what algebra is telling me right here is, sure, these can be equal, as long as 2 equals 5. In other words, if I add 2 to something, it should be the same as if I add 5 to that same number, because that's the only way that this is going to equal that. You can't add 2 different things, 2 and 5, to the same number, x, and get the same thing. That's impossible. So algebra is telling me there's an issue here. That, well, you want these to be equal? Okay, then 2 must equal 5. All right, what does this look like in a graph? Well, these each have a slope of 1, and they have different y-intercepts. So let's graph them really fast, and we'll see what it looks like. One y-intercept is at 2, and it has a slope of 1, so I'm going to go. There you are. So that's this one. And then the other one looks like this. It has a y-intercept of 5. 1, 2, 3, 5. It crosses here. It has a slope of 1, so it always goes over 1 and up 1, over 1 and up 1. I hope you can see how, as I do this, all of the things you learn in algebra get used in some way, shape, or form for the rest of high school. That's why it's very important you learn this, why it's a foundational math class, and also why showing your work is so important, because you gotta get used to these steps. Okay, so notice, these are my 2 lines. What do we notice about them? They have the same slope. What do we remember about same slope? Same slope lines are parallel. Those 2 lines are never going to cross. Now, earlier problems, we saw where they crossed, and it showed where they were equal to each other. Here, they never cross, which means they can never be equal to each other. The answer to this is no solution. Because there's nothing I can make x so that when I add 2 to it, it makes the same thing as when I add 5 to it. That's impossible. Okay, so that's the answer. The answer is there is no answer. There's no solution. This one, however, notice x plus 2 and x plus 2 let's see here. When do those equal? What number plus 2 equals the same number plus 2? In fact, these are identical, aren't they? So no matter what I make x, it should be equal to itself. So it should be equal to, if I add 2 to it, it should be the same as when I add 2 to it. So what happens when I try to solve this one using algebra? X plus 2, x plus 2. I'm going to take away 2's from each side, and that's going to leave me with x equals x. It is what it is. And then if I try to subtract x's from both sides, I can do that. I get 0 equals 0. A lot of math books and things will say, well, if you can break it down to 0 equals 0, then that means there are infinitely many solutions. Okay, what does that look like with a graph, though? Good question. I'm glad you asked. Well, these are identical. They're identical. So I'm going to graph y equals x minus 2 for the top one, and y equals x minus 2 for the bottom, or plus 2 for the bottom one. What's that going to look like? Well, let's take a look really fast. I'm going to cut and paste this because it's faster. I think it's faster. We'll see. Maybe I have to erase the whole thing. Well, at truth time, I'll put that down. I'm going to erase some things. Erase that. Yes. Heck yeah. Okay. So this one crosses at plus 2 and it has a slope of 1. So kind of here's what's going on, just to be very clear. I'm going to graph 1 in green. And I'll graph another one in, I don't know, purple. So I'm still graphing 2 lines. The thing is, though, they're not really 2 lines. They're the same line twice. When do these 2 lines cross? Always. Always. In other words, when I say infinitely many solutions, that means x could be absolutely any number, and the equation would still be true. X was 10. That'd be 10 plus 2 is 12. 10 plus 2 is 12. 12 equals 12. Look at that. If x was 100. 102 equals 102. No matter what I make x, this will equal that because they're identical. Okay, so that's what infinitely many solutions means. Infinitely many solutions. Okay, we're going to solve this one for r. Now we're using algebra to solve things that don't have just a number answer. This is called a formula. Working with formulas is really important, especially in science. So let's see here, we get our c equals 2 pi r. I want to solve for r. Notice 2 and pi are being multiplied by r. So what can I do? I can divide by those. So here's what it looks like. I'm going to divide by pi and 2 here. 2 pi. Just so you know, it's okay to just type pi. You're in a computer situation. Computers actually know what that means. So in a lot of situations, if you just type pi like this, the computer will be like, oh, yeah, I know what to do with that. Okay, I'm going to put 2 pi here as well. And what's going to happen is I'm going to end up with C over like this. R. The cool thing about this is I don't know any of the numbers. I can still do math with it. Let me write in my fractions so we can see. Sometimes I'm not completely clear about some things. There. Okay. This is an answer. All I did was divide both sides by the same thing. I'm allowed to do that. 2 pi is a number just like anything else. It's just because it involves pi, a cool looking number that we've learned about that's fancy, doesn't mean that the rules of math have changed. I can still divide both sides by the same number and it works. I believe I might have to stop so that the video will work. So I'm going to stop here.